Okay, so today we're going to look at a higher trig question from the 2000 past paper, paper 2, question 5. Solve the equation 3 cos 2x plus cos x equals -1. So, we know, or we should know, that the expansion of cos 2x can actually be rewritten as 2 cos squared x minus 1. Now, on this side there are actually 3 expansions for cos 2x. Cos 2x, whoops, make sure it's in the frame. It's cos squared x minus sine squared x. 2 cos squared x minus 1. And 1 minus 2 sine squared x. Now, a lot of people often ask, how do I know which one of these 3 to use? Well, the key is, you actually look at the other trig term within the equation. If the other trig term's a cos, use a cos version. And if the other term happened to be a sine, use a sine version. So then the question arises, when would you ever use this version? And the answer is you wouldn't. It's effectively never needed. From this, these two are derived, which is why that one exists, but you'd only ever use one of these two. And because the other term is a cos, we use a cos version of the expansion. So, taking that into the question, so we would have 3 brackets, replace that with this, 2 cos squared x minus 1 plus cos x, and I'm actually going to bring my -1 over, make it a +1, as we can see there. Okay, so now I'm going to multiply out, so 3 times 2 cos squared x gives me 6 cos squared x. 3 times -1 gives me -3. I have a plus cos x and a +1. So taking all like terms together, we have 6 cos squared x. We have a single cos x. And we have a -3 and a +1, so we have a -2. Like so. Then what we do is, we want to factorize this, and it is a quadratic, but it looks a bit horrible the way it currently is. To factorize this, we simply make a statement, let cos x just be x. And that way we can rewrite this as a normal quadratic, so we effectively get rid of the word cos. So that becomes 6x squared, that becomes x, and that becomes, well, still stays the same as -2. This is significantly easier to factorize than that. Okay, so let's factorize this using trinomials. Obviously you have to decide, will you be using common factor, difference of 2 squares, trinomials, or quadratic formula, and use the appropriate version. More often than not in higher maths it's trinomials. So it'll be 3x and 2x, 2 and 1, plus and minus. Yep, that gives me, if I multiply that out, that gives me this. Once you've factorized, you replace your x's with cos x again. So it was this, replacing cos x with an x was a temporary measure to allow us to factorize. Once we have factorized, we basically replace the x's with cos x again. So that will be 3 cos x plus 2 and 2 cos x minus 1. Like so. Okay. Now we can solve each one individually. This is just like Nat 5 trigonometry now. There's nothing spectacular about this. So we would have 3 cos x equals -2, which means cos x is -2/3. And let me just move the light source a little bit. There we go. And x is cos inverse of positive 2/3. We do not put a negative into the calculator. This would be a paper 2 question, calculator question, because it's not an exact value. So we grab our calculator over here, and we make sure it's in degrees, make sure it's in the correct mode. I think you can just make it the D there. So shift cos 2/3 gives us 48.2. Now, we do our cast diagram. Now, people often ask me, when do I do the cast diagram with trig? And the answer is, always. There will never be a time when you don't use cast diagram within higher maths. So if it's trig and you're solving for x, you're probably going to have to use cast diagram. And strictly speaking, this should have been a negative, so we tick the two quadrants where cos would be negative, which is obviously these two. So x is 180 minus that, and 180 plus that. So that's 131.8 and 228.2. You can round it to three significant figures, 132 and 228. I don't think the SQ will really be too bothered either way. We solve this one now. So that means 2 cos x equals 1, and therefore cos x is equal to a half. In fact, I'm going to slide this over here so I have a bit more space. And that means x, take your cos over, it becomes a cos inverse of a half. This is an exact value, but considering it's paper 2, if you want to use a calculator, you can do. So cos inverse of a half is 60 degrees. You again do a cast diagram for this section, and you pick the two quadrants where cos is positive because it was a positive half. These two. So that means x equals 60 and 360 minus 60. In other words, x is equal to 60 degrees and 300 degrees. Now just to finish off, we do one final line and list all the answers in order. So we would have 60, 132, 228, and 300. Finally, we just need to make sure all our answers are within the range they asked for, and indeed they are. I mean, the answers that they want are between 0 and 360, and ours fill out that range quite nicely, so there won't be any more. And that's it. Hope that was helpful. Thanks very much.